So welcome back guys, I'm sorry. We're going to go ahead and get started again with net ionic equations um, and how that affects the conductivity, whether it's a weak, strong, or non-electrolyte, and which are the ions that are causing the conductivity, if there is any. So today we're getting started with potassium hydroxide and ammonium iodide, right? So potassium hydroxide and ammonium iodide, here we go. Gone ahead and taken the liberty of setting us up with our molecular equation. Just for the sake of time, I don't want to make this video too lengthy. So we have potassium hydroxide, ammonium iodide, and that's going to yield potassium iodide, ammonia gas, and H2O liquid. Now, some of you might be saying, well, shouldn't it be ammonium hydroxide? And technically it is, but ammonium hydroxide, again, ammonium hydroxide, I should say. Ammonium hydroxide is unstable and it dissociates into these two products. So it dissociates into water and ammonia gas. So that's where I came up with that. Okay. Now you want to keep in mind your solubility rules. If you have them nearby, that should explain why this is. Again, this is a weak base. Or you just want to memorize them, okay? So we're going to go ahead and get started with our total ionic equation. Again, the solubility rules are going to help us determine this also, not just the molecular equation. So total ionic equation, we're going to start with potassium hydroxide. Now potassium hydroxide is a strong base, so it's going to fully dissociate in water, or dissolve in water, I should say. So we're going to get K plus ions plus OH ions, right? And I'm just take this one step, one molecule at a time. So now we're going to look at ammonium iodide, and that's going to also dissolve into ammonium ions or cations and plus iodide ions, right? Now these ions are all aqueous, but that's kind of implicit because they're in solution. So we're not going to go ahead and worry too much about writing them. Just remember, if we had a gas on this side or a solid on this side, that we wouldn't be able to, that we would have to put the state of that molecule. We wouldn't be able to ignore it, okay? So again, on the other side, we're going to get K plus ions plus I minus ions plus, and this is where it is that I was talking about. So here, ammonia doesn't fully dissociate in gas in water. I'm sorry, it's a gas, so we need to put our state. It's a gas. There's no ions. Plus H2O, and we can't dissolve water with water. So that stays as a molecule also, and it's liquid water. So we want to make sure we go ahead and put that. Okay. So for our net ionic equation, now our net ionic equation calls for ions that are only part of the reaction. So those ions that are found on both sides of the equation, in this case potassium and iodide, those are called spectator ions. And in our net ionic equation, we don't want them because they're not really part of our reaction. They're kind of just sitting on the sidelines and watching the players play. Right, in terms of a sport, whatever sport you may like. So we're going to go ahead and get rid of those for our net ionic equation. So our net ionic equation is really only going to have hydroxide ions plus ammonium ions. Right, and that's going to yield our NH3 gas plus H2O liquid. Okay. Now, as far as the conductivity of this is a weak base. So again, if we had our solubility rules nearby, we would know that this is a weak base, and therefore we know this is going to be a weak electrolyte. Okay, now the predominant species in solution is going to be ammonia molecules and water molecules, right? But there are going to be very, very few hydroxide ions and ammonium ions. Okay, so again, key points to this are, know your solubility rules, pretty much. Determine which are your spectator ions. In this case, we had potassium and iodide. And for your net ionic equation, eliminate those. And know how to determine whether it's a weak electrolyte or a strong electrolyte, and what are the ions that are found in solution, if any. So I hope you guys learned something today. And yeah, hope to see you in the next video. So we're going to go ahead and get started on the new slide really quick. And this is what we had. So we had